All right, so last protocol. Oh, hurry up, move those mice. Hurry, hurry, hurry.
Let the mice squeak. Oh.
Do you want to stop? I know.
Oh, you're gonna be over on the other side.
Oh, okay.
Yep.
Oh, I wasn't sure.
No, you're okay. All right, so our last protocol. So we are gonna do orbits.
You know, we should make them do a practical, test their skills real quick, like, see if they're qualified to work at U of M.
Right? Agreed.
We'll be the judges.
We'll be the
Yeah.
judge.
Should we make them come in here and show you how to do the orbits?
Sure, why not?
Yeah.
We have the time, don't
Show us what you
We
got.
got an hour.
Nice. All right, we're gonna pull over orbits protocol under our user. Make sure you're under user, because we want our protocol from our hospital, Owens Community Hospital.
I like how real you guys really try to make it. It's my favorite.
All right, so according to your protocol, the first thing you're gonna run is what?
T2 flare.
A T2 flare. So we would have already ran that sagittal. So go ahead and pull a better sagittal over
Yeah, you
to
can
run.
keep that sagittal above it.
You can just make your sagittal run.
You can sassy right now.
Everyone's getting sassy right now.
Okay,
There's
Yeah, I know. Yeah.
T2 flare. It's through the entire brain. I'm gonna give you a minute to set this up because we've done hundreds of axials by this point, right?
Doesn't say T2, is that?
What do we need to make sure that we
You just
check?
need to make it T2. Inversion time?
Yep, our time of inversion. According to our manual, what do we want it to be?
2,000.
Not 1,000.
Details,
So,
details.
no, there's our MRI quiz.
Long, long.
App that you can get, and take up to $600.
Oh, wow.
And I took everybody's, so they provide, and it gives you explanations.
Awesome.
So it's just like MRIquiz.com. And you can take it as many times as you want, and then it offers.
Sorry, I
See
thought
ya.
she was aware of all that, so.
Good seeing you guys. Keep in touch.
We will. I'm sure you'll see us.
Nice to meet you guys.
We'll probably see you
Have fun, guys.
Okay, T2 flare axial of the brain. Make sure you check your times of inversion.
Great. Go. We're supposed to go right to go.
We have class going
I was
on.
gonna read that sign
You're
right
gonna be on the other side.
Don't leave me hanging.
You don't have it in your other one?
Got it.
Yeah.
Got it.
No, it's not over there now.
All right, do we have it set up? We checked our time of inversion. You would just tell me then what it is. If it's
Okay.
still there to help you out. All right, we can go ahead and run it. We're T2 weighted. Everything's covered. So what's it telling you to set up next? Yep, T2 coronal high res for the orbits. Alright, so we've already ran our axials through the entire brain, so we can pull over a better axial, right?
I think it would be because the eyes are fatty.
Now, yours looks good. Some of the protocols say fat set,
Whoa.
some do not.
Does it look like
Okay, so that says it's a T2 coronal fat sat, and this says we're doing a T2 coronal, and it's not fat sat, so what you're gonna
It is a
do
difference.
is take out the fat sat. So some protocols say fat sat, some don't on this. If you open it up, it's not gonna have it on. There you go. And then to check it, you're gonna go under your, I think it's your resolution tab. Maybe it's under contrast. contrast tab, fat water contrast, see how it says standard, that means it's not on. So if you wanted to turn it on, see how you could just click on the fat saturation.
Do we want to turn fat
We
saturation?
don't want it on,
We
your
want it on standard
protocol, yeah,
though? Okay.
your protocol says it's just a regular T2
Okay.
coronal. I'm pointing this out because most of them are coming up as the regular T2 coronal high res, but yours says fat sat. And it's truly not fat sat, and we don't wanna do fat sat.
We don't want no fat here.
Alright. Did everybody pay attention in case you get that license where it does come up and it says fat sat and you know what to do?
So I changed it. Good job.
Alright, so it says your field of view, so once again, dedicated for the orbit, smaller field of view, smaller slice thickness and gaps, higher resolution. So yeah, they're putting in a field of view of 160, what's your phase direction going?
Right to left.
Everybody going right to left? Do we have any anatomy that's outside our field of view that could potentially wrap? So make sure we have a little bit of phase over sampling on, okay? Slice thickness is 3, our gaps at 0. Okay. Now it says to set up your slices appropriately, so we wanna find our orbits on our images, right? So we're gonna scroll through our sagittal image, look for our orbits, our axial image, find your orbits.
Those ones. Huh, simple. Just eyeballs.
Yeah, I went back to that one picture. Other one, that one, cause you can see the optic nerve in it.
Right there.
Right there?
Yep. You can kind of see it coming out right there. You can look at the other eyeball too and see if you can see it better on your other eyeball. No. Yeah, just go through to the other one. Keep going. Oh, you can see it right there too, but keep going. We got 2 eyeballs to look at, right?
Yeah.
Yep, so go back. 2 clicks. Now it's 1 more. You can pick which one you want to go with.
Okay, yeah.
This is a quick protocol, I feel like.
Quick protocol, oh well, you know.
Don't say that.
Well, no, like, the other one took,
Okay.
this one took forever.
See it coming there. So you have your your inferior rectus muscle, and you have superior rectus, you have optic nerve. You can kind of see them coming off there. Whichever one you wanna go, Rocco. It's just gonna be a slight angle, okay? So when you're looking at your sagittal image, so 2 things. Sagittal image, so our slices, we're gonna angle perpendicular to that optic nerve, so we're gonna have a slight angle on there. And then on this axial image, so we need to cover all the way back through our optic chiasm, right? You need to be through it, okay? So it's okay if you're, several slices into your midbrain. So we're covering the lens of the eye. Okay, we don't wanna cut out any, so we're gonna cover all of our, the globe lens of the eye all the way back through, our optic chiasm. Okay, so you're gonna wanna be back through there, so we're gonna need to add a lot of slices, right? optic nerves, right? So those optic nerves, one in each eye, they come back and they converge into that optic chiasm. Oh, what was that? We're on here, we're not done. Looking good. Are we T2 weighted?
Yes.
We're going right to left, we have a little bit of phase over sampling on. How are we doing over here?
Why couldn't you?
So it must be hung
That
up
was
right
the error.
now.
There's a
I didn't
lot
even make
of
it, I didn't even make it here.
So just
You
know,
did?
like
It's
they
like-
have 27.
Yeah, but I was on that side.
Oh, were you?
Jump scare.
No. She probably already feels pressure because we're in here. I didn't realize the practicals we do this week. Yeah, I know, but I didn't realize practicals were going this week.
So, no, you need to be back through, this is your, optic chiasm here, okay? You need to be all the way through it.
Oh.
Oh, when you meant too high, you meant that.
Like, it was up to, yeah.
Don't.
Loves the break.
You might even almost need 28.
I believe I was.
So just make sure you guys aren't cutting it too tight where you're gonna end up not being completely through your optic chiasm, okay? So on your sagittal reference image, you're making sure that those slices, one, that you're centered over that optic nerve, two, that you're angling with the optic nerve, you wanna be perpendicular to it. When we're looking at our axial reference image, okay, we're covering from the lens of that eye, you wanna be completely through the optic chiasm, so make sure you're a couple slices into your, okay? We've got right to left, a little bit of phase over, we are T2 weighted. Our voxels, what are our voxels at?
0.8.
Oh, 0.8. What do we need
No.
to do?
Lower.
Change them. So let's go, under resolution tab. Go down to where it says base resolution. So you, we're gonna go ahead and make it 256.
I'm just writing all this.
So we just went from, a resolution of 192 to 256. So what did that do to your voxels?
Made it 0.6.
Made it 0.6. It made that voxel size smaller, right? We went up in resolution, so when we went from 192 to 256, we're giving it more resolution. Okay.
Is there any significance with 256 or is just, okay,
But not really, I mean, you can go up higher than that.
okay.
I mean, you can go but watch what it does to your time. So there's always a trade-off with everything, so
That's okay.
type 192 back in there, okay? So we started with 192, look at what our signal is, 106, our time is 2:37. Alright, so now type in, that 2:56 that we changed it to. Yep. So now it just increased our time, right? Increased our signal. So as we get farther and farther into physics, you're gonna learn there's always a trade-off between signal and resolution,
Okay.
okay? So if we're increasing one, a lot of times we're decreasing the other. Everything's a trade-off in MRI. Okay? Everybody good with that? Everybody see how to change that? Alright, we can go ahead and, proceed, or go. Sorry, on Phillips it was always proceed. Proceed means it's good. Alright, what's the next one it's telling us to do?
T1 axial. Set.
T1 axial FATSAT, dedicated orbits, alright? We just ran a coronal, so we are going to need to pull over a better coronal now. Yeah.
Okay.
Yeah, now you're gonna have some. Yep, good job. Okay, scroll through that coronal until you find your orbits, and you can delete that sat band too, that pops up for you.
Oh, no, just kidding.
That was a scout.
They like to
Oh,
be.
yeah.
That's a scout too, that's an inside.
Oh, what the heck?
Where do you see the word scout?
I see.
When you hover
Oh,
over it, it
scout.
tells you, yeah.
I said scalp. I was like, what?
There it
There
is.
we go.
Alright. So we're doing T1 axial FATSAT. These are thin slices through our orbits. We just ran a nice coronal, so we're pulling over a better coronal to look at. We're gonna find our orbits on there. We're gonna use a field of view of 160. Okay. What does it say your phase direction's going?
AP.
Okay, we're doing a coronal. What do we want it to be? What should it be?
Oh my gosh.
Oh, I'm sorry, no, we're doing an axial. I'm confusing myself. We're on axial, right?
Yes.
Sorry. What do we want our phase to be? Right to left. Okay. Do we need phase oversampling on? We need a little bit of, don't we? That smaller field of view. Okay, so field of view 160, we changed our phase direction to go right to left. We're doing a slice thickness of 3 and a gap at 0. And now it says to set up slices appropriately with coverage of anatomy needed, okay? So let's find our orbits on that coronal view, yep. So look at where we're at.
Oh, no, like,
Yep.
yeah.
Okay. I mean, it takes a while to get used to that and know.
It's terrifying.
Yeah, so what are those two dots right in the middle?
Is it the optic nerve?
Yep. We're gonna center right over those, and then watch what it does with your sagittal image. on the sagittal one though, we just need to give it an angle, cause we wanna go parallel with that optic nerve on that sagittal image, so we need to angle that a little bit. There you go. And then I pull it a little bit more inferior again. Now the one thing we're gonna do too, so see this is our field of view box. We want to go more anterior, we don't want that box to be right on top of those orbits, that's what we're looking at. That's what the radiologist is looking, there you go, right there, that looks good. Okay?
So center it in that.
Yeah, we want some space there, right? Cause otherwise, when that image comes up, when they look at the image, if it's like this, okay, this is what they're looking at, and it's right at the top of their image. Like their window,
Okay.
viewing it, so, yeah, we want a little bit of space in there.
Okay.
So if you're centering blank, close to that optic chiasm, you're good. Now we're gonna look at this then. So when we're looking at our sagittal reference image, we wanna make sure that we're not cutting out the superior rectus muscle or the inferior rectus muscle. Okay? Can maybe get rid of a couple slices there. There we go. Probably don't wanna go much tighter
Yeah.
than that. So if we scroll through this, we can pull that whole thing down just a little bit more. Okay? So here's the globe of our eye. So if we're looking at this, that eyeball's dark. What weighting do you think this is? There's a lot of fluid in that eyeball. It's very vitreous. So what weighting would that be? Yep, it's gonna be a T1. Okay, and then if we're looking around our spine, all of the CSF is also dark. That's a T1 weighted image. We have a lot of orbital fat that's around the muscles and that optic nerve. So that's why that's bright, right? Because it's a T1. But we're looking, so we've got superior rectus muscle, optic nerve, inferior rectus muscle, it's all in there. We like our angle. Okay, so we have 13 slices at 3, thickness 0 gap, that looks good. If you scroll, like blow up your coronal image for me. Okay. We can see optic nerve. And then you can double check there too that you're not cutting off superior, inferior rectus muscle. So if we look right there, go, yeah, you can stop right there, that's fine. Okay, so we've got superior rectus muscle, medial rectus muscle, lateral rectus muscle, inferior, okay, optic nerve, all of this bright is that orbital fat that surrounds the muscle and the optic nerve. If we blow up, well, this is right here's our optic nerve here. Optic nerve, so this would be the globe. This would be the lens. We have ethmoid sinus right there. Medial rectus muscle, lateral rectus muscle. Optic nerve, basilar artery, fourth ventricle. Here's our right and left internal carotids. What lobes are these? Yep, those are our temporal lobes. Okay. Are we T1 weighted? for this, we're gonna angle a little bit more, and we need to leave space, okay, so we're not right over the top of the eyeball there. There we go, optic nerve right there, so we wanna
Yep.
go parallel
That's
with
right.
that optic
Mm.
nerve.
What my
Make sure-
notes
yeah,
are
We're gonna
make
angle
sure.
a little bit more, we're gonna pull that,
Try.
that thing down.
Tomorrow for my lab, I'm going over everything,
Making sure that we're not
maybe 3 times.
cutting out
I'm like
our
debating
superior rectus muscle or
There's
inferior
technically
rectus
something
muscle.
to tell me after when making my eyeliner.
So for this field of view, we need to leave some space up there, so it's centered
Cause that's the
roughly
last time we can
just in
practice.
front of like your optic chiasm right there. And you can kind of see where these tracks come down too, a little bit.
I don't wanna stay longer. Yeah.
All right, are we T1 weighted, everybody? We're going right to left, we're T1 weighted, what else is it asking us to do? Oh, shin box. Yeah.
Look at this dark. That.
Okay.
Oh, it's so scary.
Now, your fat sat box, so there's 2 things here, so go underneath your resolution again. Oh, I'm sorry, contrast. Somebody's got some doors going. So see, under contrast tab, under your fat and water, now it says fat satted,
Okay.
right? So we're good there, I just wanted to point that out. So go ahead and go back to your routine tab. Now go up to that drop down arrow and see all the way to the right where it says add volume, click on that. Right, that green box is your shim box. That's your shim box. So when we're adjusting that shim box, we're teaching you that A, we don't want it outside of your field of view and we don't want to shim air, okay? So us Siemens users, we don't really adjust this a whole lot, like GE people do. We're gonna show you. So you're gonna bring this in, okay? Because this is all air up here. And then we can bring this in a little bit more side to side, okay? But I'm good. I'm just shimming my eyeballs, my optic chiasm. We can probably come in a little bit more. And then see how it adjusted it over there. Now, all of our images don't exactly match up. So if I try to put this one inside, it's gonna make it too small on that sagittal. Typically, they should match up, but this is a simulator, so, it's not. So just make sure you have it appropriate on your axial and sagittal image for me, okay? Alright, so we would, so this shin box, we're gonna bring that in.
That's
Okay,
right,
cause we don't
okay.
wanna shim air, that's all
Yeah.
air out there.
We need to be correct.
So we'll just bring it in, let's outline elements, and we can bring it in a little bit more side to side.
How do you get it?
You go, this little arrow here. You hit the add volume, and a box will pop up for you. Welcome.
You got it?
So when we're dealing with shimming, cause we're trying to make the area where we're looking at nice and homogeneous, air is gonna blow it out. So we're gonna bring that box in up until it moves into the orbit, and then we're gonna shrink it down. So we don't ever want the shim to be outside our field of view or our slices, and we don't want to shim air at all. And then we can bring it in a little bit more side to side too.
And the scrubs?
That's the.
Is it Chelsea? I don't know. I've never had it.
Oh, yeah, our field of view, you could just type 160.
Alright, tell me what's wrong with this picture.
Antenna effect.
Good job. Well, now he's not ISO center.
So how's?
He's not even in ISO center
Now
yet.
he's not in center.
And then you can see how
Failed.
it adjusted it on the sagittal.
Surgery
an
repeats.
adjustment here too, but once you do that, it's gonna change it on there. It shouldn't, but because it's a simulator, so if you were to take this and try to make that smaller, it's gonna change it.
Albert Einstein. Is that Albert Einstein? Nope, this is Albert Einstein.
But as long as you have it, appropriate on your
Beethoven.
axial, set.
It's got the hairs back to it. It's a one-time conductor.
All right, any questions on that? Did we check everything?
Yeah.
Okay, go. Last one.
Sad.
Oh, here was a question for you too.
No.
Should we remove makeup for orbits?
Yep.
Yes. Good job.
Never reading that.
And there's so many things that you gotta watch out for. There's magnetic eyelashes now. When you have like a woman that comes in and she has like real heavy like black eyeliner, you know, tons of eye makeup on, you can actually see on your images where you're getting artifact. Like if you're running a routine brain, for instance, you can see where you're getting artifact around the orbits from that makeup. So,
What if they have, so it's like a thing now, permanent, like makeup kind of like that?
Yeah.
Does that affect it all, or?
yeah, I mean, it could. So just like permanent eyebrows, they just like any tattoo
Okay.
type of thing, it has that potential to heat up.
Okay.
So that's kind of why those questions are on our screening form and why we ask, because we would want them to squeeze the ball. Should they start, but realistically, when they're already feeling it, it's already happening.
Okay.
So,
But it would be the same like treating it as a tattoo, basically, like, where'd you get done, how long ago, professionally? that kind of
yeah,
stuff?
and you
Okay.
would just wanna have that conversation, you know, with the patient and talk to them and check in, make sure that they're not feeling like tingling or any warm burning sensations or anything like that. All kinds of stuff that we gotta watch out for. But yeah, makeup does cause artifact, I'm not, it will cause artifact. Alright, last one, it says a T1 coronal fat sac, thin slices for your orbits. And does everybody have that, or is there one phone call or license on here that, so you have T1 coronal fat
That's the
sac,
box.
thin slices, okay, do you guys have it? Yeah, T1 thin slices. Do you have it on yours? Okay, perfect. Alright, says we're gonna do field of view of 160. What's our phase direction going?
Right to left.
It's going right to left. We gonna need any phase oversampling on? Is there anything going right to left that's gonna wrap in?
Yeah.
Gonna use a slice thickness of 3, a gap at 0. Set up slices for coverage. Well, we already did a coronal, didn't we? Through the dedicated orbit, so we're probably gonna want it to match up with that, right? Use the same number of slices. Now the weighting's different. Good job. How are we angling? Yep, on that sagittal reference image. We're gonna go perpendicular to that optic nerve, right? Good job. Coverage is from the lens of that eye back all the way through your optic chiasm. we can also verify on our sagittal image too, if we're through our optic chiasm, right?
Parallel with the optic nerve.
Both parallel.
Or perpendicular, sorry. But the white line will be, that white line needs to run parallel with the optic nerve.
Not the white line, the black line. Oh, you're talking about that.
Yeah. There you go.
And then, yep, you're gonna bring that center down a little bit, good job.
That needs to come back.
Yep.
I like how it just doesn't, like, move everything for you. Scroll through your pictures. I think as long as you're centered in between those optic nerves, yeah. Yes, I was trying to think, that's what it is.
Left.
There's picture number 2, toxins, but I like the stormtrooper. Right. If you x-ray the stormtrooper.
That's it, right?
Shin box for that.
That's good there. So 2, 1.
You need that green box.
Ah, yes, the green box.
Mhm.
That's what I forget.
What are our voxels at?
0.3.
When you change the voxel size, how did you do that?
So head to foot, we can come way in, can't we, if we're looking at the sagittal and the coronal view? So we're gonna keep that larger right
Keep that
there.
larger,
Yeah, cause
okay.
we wanna take that all the way through the optic chiasm. Yep.
Okay, those smaller or keep it there probably.
It's close enough.
Okay.
Pull it back just a little bit so it looks like it's outside your slice. There you go. So if we look at our sagittal and coronal reference image, so we can bring that in. Not the sides, not the, yep, the head to foot there, we can bring that and see how it's shrinking it on your
Okay.
axial. There we go, that's probably pretty good.
Okay.
And then maybe just bring it back out again. See how your sagittal and that axial image, you wanna take that anterior, so you're, questions on anything? Anatomy, coverage. Are we good with anatomy?
Such a child. Like you're doing MRI, you're pregnant. Do you think you're good?
Yeah, you can. Amanda and I were looking at pictures of it yesterday, it's creepy. You know how that looks, now that's creepy.
Cool.
It's a little tiny, creepy, neat.
The future.
Any questions? Do we like it? Did we do everything? Alright, how you guys feeling